Hello Year 13. So today we're going to look at how to draw a ray diagram for a refracting telescope in normal adjustment which shows three non-axial rays. So the first step is to draw a horizontal line across our sheet of paper. So I've got a piece of A4 paper, I've turned it landscape and I've just drawn a line all the way along the middle like so. So this is going to represent our principal axis. So I'm just labelling it up on the right hand side here, really nicely out of the way. I'm also going to mark up where I want my first lens, and I've put it just over 8 centimeters from the left hand side of the page, and I'm going to draw the principal focus for this lens, 8 centimeters F, and I'm going to call it O, and I'll explain why it's O in a second. And then I'm going to draw the next lens 4 centimeters away from that. So I'm just going to draw the vertical lines. These vertical lines are the lens axis for each of the two lenses that I'm going to draw. And I'm going to show that they're converging lenses just by drawing tiny little lenses at the intersection of the lens and principal axes. As I mentioned a second ago, this is 8 centimeters. This is the focal length of the first lens. This lens is more powerful. This has a shorter focal length, and this has a focal length of 4 centimeters. This means that the focal length of each of these lenses is coincident. So I'm going to label this first lens as the objective lens, and this one over here is the eyepiece lens, and I will draw arrows just to show the focal length of each lens. So from here to 8 centimeters, and from here to there, that's our 4 centimeters. Just going to adjust the exposure slightly. So this is, as I said, 8 centimeters. This is 4 centimeters. This distance represents the focal length of the objective lens, and this distance represents the focal length of the eyepiece lens. The objective lens is called the objective lens because it points towards the object that you're looking at. The eyepiece lens is called the eyepiece lens because it's the bit that goes next to your eye. And I'm also going to draw a dotted line here which represents the focal plane. Let's label that up as focal plane. That would make this the principal focus. That would make that the principal focus. So I think we've got everything we need ready to start drawing our rays of light. These are the lens axes. I'm not sure if I mentioned that previously. So our first ray of light needs to go through the centre of our objective lens. When we looked at ray diagrams yesterday, we saw that any ray of light that travels through the centre of a lens is undeviated, so it doesn't change direction. So this is quite useful for us. And I'm drawing it non-axial. So if I'd have drawn it parallel to the principal axis, that would be axial. If it's non-parallel, that would be non-axial. So I'll start off towards the left hand side of my diagram, and I'm going to draw a straight line. It's going to go straight through the centre of my lens. It's undeviated. It goes through the focal plane. Now there's nothing at the focal plane that's going to change the direction of the ray of light, so it does not change direction here, and I'm going to stop when I reach the lens axis for the eyepiece lens. So that's that's all good so far. So that's my first ray of light drawn. I'm just going to put a little arrow here to show that the ray of light comes from the left and heads towards the right. And now I know that anything that enters this objective lens parallel to this first ray of light will now be refracted through this point on the focal plane. So that's good. My second ray of light I'm going to draw parallel to my principal axis whilst it's inside the telescope, and it's also going to go through that point on the focal plane where our first ray of light did. So I think we're good here. So that's our second ray of light travelling through the inside of the telescope. Now, when we looked at rays of light yesterday, if they enter a lens parallel to the principal axis, they're going to travel through the principal focus. And the opposite of true is true. So if a ray of light exits a lens parallel to the principal axis, that means that it must have travelled through the focal point. And the focal length of this lens was 8 centimeters. So let's mark up our other principal focus for the objective lens, and we'll do the same on the other side of our diagram. This time it's going to be 4 centimeters. That's the other principal focus for the eyepiece lens. So this ray of light must have travelled through at this point. So we can draw it like that, and because it's entering this lens axis parallel to the principal axis, it's going to be refracted and it's going to travel through this principal focus for the eyepiece lens. And it will look like that. Again, just a directional arrow to show which way the ray of light is travelling. Now, you'll notice that these two rays of light are parallel, and this suggests that when this ray of light leaves the eyepiece lens, it's going to be parallel to the second ray we drew, so we can complete our first ray now. So as best I can, I'm going to make this one parallel to our first ray of light. Yeah, I'm quite happy with that. I'm just going to draw 3 dashes on each of these to show that they're parallel to one another. Over here I've drawn 2 dashes to show that these two are parallel to each other. So I've now drawn 2 non-axial rays. I now need to draw a third, and it would make sense to make it symmetrical, so I'm going to draw a ray of light that's parallel to the first two, and I want the distance between these two rays to be the same as these two rays. Okay, there it goes. Because it's entering parallel to the other two, it's going to be refracted to this point on the focal plane. So we can go from here through that point on the focal plane where all the other ones converged, undeviated until it hits the eyepiece lens, and then that is going to be refracted. It's gone through that point, so it's going to leave parallel to the other two, and as best I can we have our last ray. So we now have 3 rays coming out of the telescope. We've got 3 rays going into it. All of them are non-axial and they focus at this point on the focal plane. So at our focal plane, this lens will produce a real image of our object. So I'm going to draw, I might use a different colour, let's try blue. I'm going to draw my real image here. And again, doesn't need to be fancy, an arrow will be fine. It's inverted, so that tells me that it's a real image. So let's label this up as well. So we have a real image produced by the objective lens. So that's here, and what the eyepiece lens does is produce a virtual image of the real image. So if we have a look at these rays of light here, because they're parallel, they're never going to converge. So what we can say, if we draw construction lines extending these, so we can see where the image would be produced, we get something like that. I've not drawn that particularly well, but they should be parallel, and this means that we would get a virtual image produced at infinity.